Hello everyone. In this video, we are going to see about a minimum spanning tree by using an Kruskal's algorithm. So just imagine yourself, you are building a roads to connect several cities. Then what do? Suppose for being an engineer, you have a tight budget. Then how do you connect all the cities with the least total cost without forming any loops? That's where Kruskal's algorithm comes in. It's both smart and efficient. So in this video, you will learn about what is meant by minimum spanning tree and how Kruskal's algorithm helps to build it and how it differs from the Prim's algorithm. So we'll go step by step. So what is minimum spanning tree? So already we have covered about Prim's algorithm in the previous session. A spanning tree is nothing but which connects all the nodes in a graph with a minimum number of edges with a minimum number of weight. Yeah, minimum spanning tree is the one where the sum of edge weight is the smallest possible. So whichever nodes is going to be connected, which covers all the vertices with a less weighted. So that's a sum which is very much smallest possible in the graph. The Kruskal's algorithm helps us to find the minimum spanning tree by sorting all the edges and adding the smallest ones first and avoiding the cycles. So unlike Prim's algorithm, which grows from one node, the Kruskal's algorithm treats the graph as a whole and keeps picking the lowest weight edge that does not create a cycle. So now we will see this example. So in this example, it contains 9 vertices and 11 edges. So the minimum spanning tree formed will be having a 9 minus 1, that is 8 edges. So we'll see step by step. So these are the weight and these are the source and destination of the all the vertices. So between 1 to 2, the weight is 1 is between the 5 to 8. So I have sorted this table by means of weight. Between 8 and 5, that's a weight value is 1. Between 3 and 5, the weight value is 2. Between 2 and 3, the weight value is 3. Between 3 and 4, the weight value is 4. 4 and 6, the weight value is 5. So I have sorted this table by means of weight. This is the first step. Once you finish the first step, once you form a table, then what I'm going to do here. So whichever uh, have a minimum weight, I'll pick it by one. So weight value is 1. So I have taken as a first step between 8 and 5, I have formed an edge. And then between 3 and 5, I have formed a weight called 2. And then between 2 and 3, the weight value is 3. Between 1 and 2, the weight value is 4. And then between 3 and 4, the weight value is 4. So what you can observe over here, here you can observe we are forming and we are visiting all the edges, we are visiting all the vertices with a minimum number of weighted edges. Between 4 and 6, the weight value is 5. Between 7 and 8, the weight value is 7. So now comes the weight value is 8 is between 1 and 7. So the Kruskal's algorithm always in the minimum spanning tree, there should not be any cycle. So now if I do it over here, the cycle is formed because of weight. So hence it is discarded. So next weight is going to be 9 between 5 and 6. So once I connect that one, it is going to be form a cycle. So it will be discarded. And then 8 and 9, the weight value is 10. Between 9 and 6, it is an weight value is 12, but it forms cycle. So it will be get discarded. So this is the final minimum spanning tree by using Kruskal's algorithm, where we have visited all the vertices with a minimum number of weighted edges. Where in Prim's algorithm, we have gone by node by node. But whereas here, we have gone by through the whole graph. Through whole graph, we have formed a table with a less number of weighted, and then we have started from one by one. So once you form its cycle path, we will remove it. We will not form a cycle path. It will be discarded. So we have visited all the vertices over here with a minimum number of less weighted edges. Thank you for watching.